folks, thank you so much who are watching this video. Welcome to my new channel. I decided to make a new CNC channel to introduce my work and introduce myself. I'm Attila, and the machine is behind me is a home-built PCNC machine, which was started to build in the last, 2 years ago, not last December, but 1 year before. It took me about 3 months to make this machine, to transform the machine from an EDM machine to a Z-axis milling machine. I would like to, in this video, I would like to explain why I choose this EDM and why I didn't make a machine using aluminum parts or such things like many people does. 2 decades at least what I spent in different manufacturing, and I have seen many different CNC machines like milling machines and nanodicing machines and so forth. And these machines, all of them built to be rigid and heavy. And 2 kind of material what I have seen, but using the manufacturers, one is the granite and the other one is the cast iron. And the cast iron was the safer I choose for me. This machine, this EDM, has a cast iron foundation or base, which is only this part of the machine. The C shape is about 600 kilo. The tank and the cabinet is plus 200 maybe. The cast iron has a very good vibration damping ability, and that's why I choose it. Unfortunately, an EDM machine, not every, but this specially or particularly this machine was not built with linear bearings, but it was sliders each other. All of the sliders are coated by Teflon, and ball screws also coated by Teflon, and the ball screws are grounded, and it has an oiler. But if I would like to make a milling machine, the vibration can lift up could lift up the axis, the X or Y axis, and is introducing more vibration. That's why I installed both sides of both axes linears, and they are prevent right now the lifting and the vibration. The Z-axis for an EDM machine, the Z-axis travel is very short, which is not good for milling, and that's why I completely rebuilt the Z. And the Z, for the Z I put also linears, and I had 2 different approach. First I used the smaller spindle, which was not so heavy like the gray one on the machine right now. I bought this other spindle, which is an SK spindle, SK taper spindle, and I can change the tools very easily. The tool change is manual, but much faster than the other. The other point is the weight of the Z. The Z weight, in my opinion, the Z weight should be as much as possible. The moving weight of the Z in this machine is about 80 kilos, and this 80 kilos is heavy enough if the machine puts the material into the tool. it won't vibrate. Hey. The counterbalance for the Z is it has many different approaches also in this way. Someone could build a chain and a counterweight on the other side of the column. Others use other ways. My choice was this gas-loaded spring, which I have seen on the Skyfire machines. They are custom built for me. They are the old ones for the smaller spindle, and right now stronger are built in the machine. It has no damping, so if it goes out, then there is no any damping, but it is good for the CNC. Actually, this PCNC machines is about the same size like the Tormac LB100. The travel of the X and Y axes are bits. They are shorter. In X I have 298. In Z in Y I have 238, and in the Z 296. Sometimes it's too short. But most of the parts that I made with this machine I could do. Mostly I mill aluminum or steel and plastic. The spindle has a belt drive and AC Fanuc AC servo motor. It's a 2 kilowatt motor with an encoder. And the motor is closed loop driven by the software, and for this way it can it's able to make a rigid tapping, for example. First I installed a industrial MPG wheel on the cabinet, but that was not the best way, because it's attached to the cabinet, and sometimes I had to work in this way, and I bought this manual hand wheel here, which is Wi-Fi connected to the PC. The other thing, when I talked about how can I to drive the axis, which way, the AC servo drive was one possibility, but actually this machine doesn't need the AC servo because the travels are very short. So, but my decision was I should use a closed loop drive. So I chose the hybrid stepper motors. They have an encoder, hybrid stepper drivers, closed loop mode driver, and there's all three axes has a 8 Nm motor. The maximum speed is 5 meters per minute you travel, and it's too much actually. And the 2.5 meter I made a reduction, and it right now is 2.5 meter, the fastest speed where the machine can travel across the axis. The software was the UCCNC, because the guys who made the software are in the same country, like living in the same country like me, and we speak the same language, and they updated it very often. If I have any problem, I just write an email, or we have a very good platform on the internet. 1 hour and latest 1 hour, and I get an answer or a solution from the guys. And thank you guys. I would like to upgrade the machine. and the upgrade is the 4-axis, folks. 4-axis. I was a very lucky guy, and I could buy a robotic joint which has a, actually here is the AC servo too, and it will be driven by AC servo, and this has a harmonic drive, no backlash at all, and the size is 25. This will be the first decision is to build it parallel with the x-axis. I have 200mm room underneath the spindle nose, and to the biggest cycle what can turn around here above the table. This is the first thing, and if it works and I have enough room, but I have to design, I don't know yet. I have this big dude here, folks. This is a 45 size harmonic drive. It has a reduction 120. The small one has 50, and maybe my machine will be 5-axis milling machine. This is the goal what I would like to reach in this year. And I have one more dream. If I if I have a chance, I would like to buy a real CNC machine, not new one, used one, which has much more travel like this, maybe 700X, and I would like to dive deeper in this CNC machining job, because I like it very well. It's so amazing, and for the design and make the programs, I use the Fusion 360. I'm not a manual G-code guy. I find this software is amazing. That's all, I guess, for now. Thank you for your taking time to watch this video. If you like this, please thumb up. If you don't, please thumbs down. And see you later. I will keep you updated. And let's see how can I to build a 4-axis. Goodbye.